Hello friends, welcome back to our channel. Today we will discuss about one algorithm in machine learning, that is instance based algorithm. So in that instance based algorithm we will see the one example, that is k nearest neighbor classifier algorithm. So in our previous session we have discussed about various classification algorithms. So in that, the first one, k nearest neighbor classifier. K nearest neighbor classification. So here the name itself indicates we need to consider the nearest neighbors in order to classify the input. So here this is a instance based process or instance based classification. Instance based classification. And one more thing, in this k nearest neighboring classification, it doesn't create any mathematical model from the trained data. So no mathematical model created from trained data. From trained data. So from where it will be classified? So the classification of new data is done from all the training instances. So first all the data, all the instances will be stored, okay, in the memory. The training data will be stored in the memory, and then it will be finding the distance among all the instances of the training data, and from that it have to select the nearest neighbors which are close to the new data, and it will identify the classes of those neighbors, and then it will find the majority of the class and it will predict the class to the new data. So this happens in the k nearest neighbors. So we'll see working. The first one, all the training instances stored in a memory. So first all the training data will be stored in a memory. Okay. Next, new data arrives. Whenever there is a new data, so based upon the trained instances, we need to classify the new data. So the next one, it calculates distance. It calculates the distance from new data to all instances. Okay, so we'll see the implementation part also. Let me explain you the theoretical part and then we'll go with the implementations, right? So calculates the distance from new data to all instances which are in the memory. Next, find k nearest neighbors. So which are close to the new data. Okay, we have to find the nearest neighbors which are close to the new data. Identify the classes for neighbors. So whatever the neighbors we found here, so we need to identify the classes for that particular neighbors. And after identifying the classes, the next one, consider majority of class. So among all different classes, we need to consider the majority. Then predict the class to the new data. For the new data, we need to predict the class. So whatever the majority we got here, that will be considered as a that will be assigned to the new data. So this is the working of k nearest neighbor classification. So here, see, we need to focus on a few terms. So what are those? First one. So all the training instances will be stored in the memory. Okay. So the complete whatever the data set we are taking, that data set, from that data set we need to divide or split into training data, testing data, training data and testing data. So after that, the next one, distance. We need to calculate the distance. We need to calculate the distance from new data. So that can be Euclidean distance, Manhattan distance, Minkowski distance. Minkowski distance. So we need to find the distance for all the instances. So here the formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square. And here is the formula mod x2 minus x1 plus y2 minus y1. And this is a combination of both Euclidean plus Manhattan with the special cases, right? So we need to calculate the distance from new data to all instances, and that distance measure can be any one among these three. So already we have discussed about these three distance measures in our previous session, right? So I'll post the complete link in the description so that you can refer for what is a Euclidean, what is a Manhattan, and what is a Minkowski. Then find the k nearest neighbors. Now we need to find the k. Here the k means number of neighbors. Number of neighbors means number of data which are close to the new data. So close to new data. So that should be defined. So k value should be defined. So whether it may be a 3 or 4 or 5, etc., etc. So usually we need to consider this as an odd number. Consider this as an odd number, because here we are what we are using. So if k is equal to 4, that is an even number. What happens? So next one we need to consider, identify the classes for neighbors. For example, there are 4 possibilities A, B, C, D, and there are classes like this is large, okay, this is a small, and this is a large, and this is a small, okay. So if it is in this case, right, or else simply imagine a student percentage, the result will be pass, and it is fail, and it is fail, and it is pass. So what happens here? We need to identify the classes. So this is a class, this is the input. So we are considering only the 4 neighbors. These are the 4 neighbors, and consider the majority of the class. So you can observe there are only 2 classes, fail and pass. If you consider the majority, there is an equal majority between these 2 things. So this is called as a tie between 2 classes. So this can be solved by tie breaking rules. Tie breaking rules. One is considering closest one among all 4. We can consider the closest one. Another one, you can find the distance, and based upon the distance you can select it. And the third one is a random way we can consider the data, so the class, right? So like this we are having a few tie breaking rules. So with the help of these tie breaking rules, so among all these things we need to select any one, and we have to select the class. So in order to avoid such kind of complex things, better to consider the k value as an odd number. For example, if you consider this as an odd number, see what happens. The fail is 2 and pass is 1. So we can go with a majority and you can consider that as a fail. So whatever the majority class it becomes, that we can assign. So very careful, we need to select the k value. That means how many neighbors we need to select, how many data we need to select which are close to the new data, right? So this is about the k nearest classification. So advantage is, so one thing, it is very simple to implement, very simple to implement. Okay, and also multiple classification can also be supported by this particular k nearest neighbor classification. And drawbacks, the all automatically there will be a drawback. What is a drawback? So it requires more memory because we are storing all the instances, so it requires some more memory, and there might be a chance of getting these kind of complex things like tie breaking, right? So hope you understood this one, and now we will see a small example. Okay, house prediction. Okay, the house prediction based upon the square feet. So we need to give some square feet from among the data set. It will find whether the area is a large or small or a moderate. So for that particular data set, we will see how to find the k nearest neighbor classification. So let's move on to the IDE.
Hello friends. So just now we have seen the complete theoretical part of k nearest neighboring classification algorithm. So we'll see the implementation part. So we will implement that classification algorithm in a Python programming. So first of all, I have taken some data set, and here I have taken some 40 samples. Okay, house ID, area in terms of square feet. Let us consider it. And the next one is a class. So I have taken the three classes. One is a small, medium, and large. Only three classes. So based upon the given area, so we need to give some area. So it will predict the class from this particular thing. So what we have to do means, first we need to train the model with this particular data set, and with this in this particular data set itself, we need to divide the data set into training data as well as a testing data, and then we need to give one input, that is the area in terms of a square feet. So it will predict based upon the trained data, so it doesn't create any mathematical model. So based upon the trained data only, it will find out the distance from the given new point to all the instances, and it will find the nearest neighbors. So that also we need to give. So whether we have to consider either some 3 or 4 or 5 or 2, whatever it may be. So it will find the nearest neighbors, and it will sort out the classes of those nearest neighbors, and it will consider the majority, right? So let us move on with the code. So here, so all the machine learning algorithms will be implemented in a Python programming, because so we can make use of an existing libraries and modules. So we know Python, in Python there will be a libraries, and for every library there will be some modules, and every module will be having a classes, and class will be having some methods. So like this, let us start with that. So we need to consider a data set, and first we need to create a data frame. That means we are considering the data set, and that should be converted into two-dimensional uh, table. So where we can use the data frame, right? For that we have imported the pandas. So the first line is a import pandas as PD. So as PD means that is a alias name, right? So instead of writing pandas, we can write PD here. And the next, what I said is, from the same data set, we need to divide the testing data as well as the trained data. So both the comes in the same data set. So for that purpose, we need to use train test split function. Train train test split function. So This particular train test split function will be available in a module called model selection. So model selection is a module, and in that module there is a function called train test split. So the complete data set will be splitted into trained data and testing data, and where this model selection will be erased. So this model selection module is available in the sklearn or scikit-learn. So both are equal, sklearn or scikit-learn. So we have written from scikit-learn, that means sklearn dot module selection, we are just importing the function called train test split. So from sklearn model selection, import train test split. Similarly, we are supposed to use the existing k neighboring classifier algorithm. So we are not writing the complete program from the scratch, but we are making use of the class called k neighbors classifier. So this is the class you can observe. So if you are using the PyCharm, so just move the cursor to that particular class, so it will give the complete information about that class. So we are not writing each and every point of this particular class, but we are making use of existing one. And this class is also available in a module called neighbors, which is in sklearn or scikit-learn. So from scikit-learn dot neighbors. So if you want to call any function, or if you want to call any module, that module should be called with the help of that particular library dot, with a dot operator. So sklearn dot neighbors, import k neighbors classifier. So it is a class. So you can observe the class naming convention. So here k is capital, n is capital, and c is capital. Now we need to load the Excel data set. So our data set is in Excel format. Okay, we need to create a data frame. So data frame df is equal to pd, that means pandas dot read Excel. So read Excel is a function to read the Excel document, and we need to give the complete path. So use a double quotation, I mean double slashes. Double slashes we have to use in the path. Whenever you are giving a path, we need to give the double slashes, because if you use only single slash, that will be considered as a backslash constant. So we need to give a double slash, or you can simply use here, or that means raw data, and you can use a single slash. Anything is okay. So I have given some double slash. So my data set is in this location. My data set is in this particular location. So the same location I have given here. So D machine learning, K nearest neighbor classification, and house prediction dot XLSX. So I'm just printing the data frame. So once the data frame was read, the complete data will be read. Okay, printed. Now we need to train the data. Okay, we need to train the data. So we need to divide both the testing data and trained data. So here, what is the input? The input is area. So because we are giving some area, based upon the area, it have to predict the class, whether it is a small area, large area, or medium area. So the first X, I am taking this particular area, column area. So here you can observe the name should be same. Here I have given area, the column name. So that I am passing it to the component X. Similarly, what is the result? Target. So target means, so where the target is this class, house underscore class. The same name you need to give here. So y is equal to df house class. So this is the input, this is the output. Now we need to give the split function. That means we need to split the complete data set into training data set and testing data set. So here you can see X train, comma, X test, comma, Y train, Y test. So both the components. So we need to give both the training and testing, both input and output. So input is in X, output is in Y. So X train, X test, Y train, Y test is equal to, we have to use the function called train underscore test underscore split, which is available in model selection module of scikit-learn. So here it will take 4 parameters. One is a input and output. That means X component and Y component. And the next one is a test size. We have given here 0.2. That implies 80% will be the training data, 20% will be the testing data. So if our data set is having some 10 records, So 8 records will be treated as a testing data, sorry, training data, and 2 records will be treated as a testing data. So here we have taken some 0.2, that means a 20% of the text. So here you can see total 40 records are there. So among that 40 records, 20%, 40 records, 20% means around 8 records will be used for testing purpose, and remaining 32 records will be used for the uh, training purpose. And the second parameter is a random underscore state. So here random underscore state means, so without any repetition, for example, if the records are having any duplicates, so if you want to consider the duplicate, if you are not want to consider the duplicates, that represents this random underscore state. So here that random underscore state is equal to 42. So is it mandatory to give the value 42? No. So any non-zero value you can give, so that will avoid the duplicates. Okay, if our testing data or training data is having some duplicates, it will avoid that one. So every time you run, and also how many records should be considered as a testing, and how many records should be considered as a training. For example, let me tell you the example. So if you consider some 10 records, see, if the testing, two parts we have to give. So one is a training data, another one is a testing data, right? So for example, in the first run, if you run this program, for example, let us take some 1, 2, 3, 4, 5, 6, 7 and 8 are the testing data, and 9 and 10. So that means these are the numbers. Consider the numbers. Record 1 to 8 are the training data, and 9 and 10 will be the testing data. So if you apply the second run, that means if you execute the same program second time, this training data may be changed. 1, 2, 3, 4, 5, 7, 8 and 9, and the testing data may be 6 and 10. And if you execute the third time, if you execute the same program third time, it may be 3, 4, 5, 6, 7, 8, 9 and 10, and the testing data may be 1 and 2, the records 1 and 2. So in order to avoid this one, okay, every time you run the data, you run the program, the training data and testing data will be different. So among that 80%, any 80% randomly will be given for the training, and 20% will be taken for the testing. But if you use this random state, is equal to a non-zero, always whenever you run this program, see, so here we are using random state is equal to from 42. Let us take not only the 42, you can take any value. So I'll give as a 25. Then if you execute a program, if it gives the data 1, 2, 3, 4, 5, 6, 7, 8 as a training data and 9, 10 as a testing data, in the second run, if you execute the same program second time, again you will get the same data. That means n number of times you execute the program, the training data will be fixed and testing data will be fixed. So for that purpose, we are going to use this random state. In our program, we are using the random state. And now we are considering what we have said. K neighbor classifier is a class. So we need to create an object. So KNN is an object of this particular class. And here we need to give the neighbors. How many neighbors we want to compare. So n underscore neighbor is nothing but a parameter which is given to the K neighbors classifier. It's a class. So this is an object. So here we have given 3. So it will compare 3 values. Okay. If it is 4, it will compare 4 values. So KNN.fit, and this particular fit function is used to train the model. So xtrain and ytrain are the components here we have given. Xtrain and ytrain. So that model will be trained with this one. So KNN.fit, that means that model will be trained with this particular K neighbors classifier or algorithm. So KNN is an object of this particular algorithm. So after that, we need to test the data. So y underscore prediction, this is one variable we have taken. So there is a one more function called a predict. So based upon the input given, it will have to predict the output. So input is in x test and output will be in y predict. So x test, here itself we have given x test. So from that we'll be getting the output. So it will not create any mathematical model, but it will calculate the distance for all the instances in the training data, and it will classify, or it will consider only the three top neighboring values, and among the three neighboring values, then it will count the majority. I mean, it will find out the classes of those three records. So after testing this one, next we need to predict the new thing. So whenever it is completely fine with this up to here, now we need to predict the new house. That means we need to give some area. So area is equal to float input, enter the house area in terms of square feet, and new house is equal to pd dot data frame area. So we need to take this particular thing into area, because this is the input we are saying, right? And prediction is equal to KNN predict, and we need to predict the class for this particular area. So that means new house. So KNN dot predict new house. New house is whatever the area we are taking, the same area. And immediately we can print the thing to which the input which we have given. What is a predicted house class? What is a predicted house class? Now let us execute this program. Simple. So I'm executing this program. So here you can get the output. See. So still it was running. So once it was run, first it will print all the data frame, the records of a data frame, and then it will prompt for the input. See. So just a second. Yes. Okay. See here, this is a complete data set, and after that, maybe we have printed the somewhere else we have printed this x. Yes, see. So that's why once again it was repeated. So I am just ignoring this one. We will ignore. So here we are removing the thing, and once again we'll execute this one. So it will execute. First it will display the complete data set in terms of data frame, and now it was asking about the house area. So here let us give the thing as 973 square feet, and let us check the prediction. It was given small, 973 as a small. So let us cross check this one whether it was correct or not. So what is the thing we have given input? 973. What happens? It will calculate the distance. So I'll manually will calculate the distance. 500 minus this one, right? So oh sorry, let us take this one, 973. Okay. Is equal to 500 minus 973. See, so here let us take it as a absolute value, so that there will be no negatives. Okay, so 473. Let us, so first the distance will be calculated for all the instances of this one. Okay, from this in our program we have taken the k neighbors as a 3 neighbors. So what are the shortest neighbors? So 23, 27 and 73. So these three. Hope you understood. Among all the distances, we are considering three nearest neighbors. What are the three nearest neighbors among all these things? Are 23 distance, that is 950, and 73 distance 900, and 27 distance, that is 1000. So among these, you can see small category are 2 and medium category is 1. So obviously it will consider the majority. So majority is a small. So we got it as a small. So hope you understood. Once again, just go with the thing. And again, we'll see one more 1022. So it will give a medium. Medium. So why medium means, again the same process, it will find the distance from 10222 to each and every area, and it will sort out with the 3 least distances. That means those are the neighbors. If there is a least distance, automatically those are the neighbors. So here we are considering only 3. Okay, k n neighbors is equal to 3. So k stands for neighbors. So we are considering only 3 neighbors. So we are just considering 3 shortest neighbors. Among that, we are just finding, or we are just selecting the majority of the class, right? So this is how we can implement the k neighbors classifier, k nearest neighbors classifier. So we are not writing the complete program from the scratch, but we are making use of an algorithm in terms of a class called k neighbors classifier, right? So hope you understood this one. And if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.